How's it, lovely matriculants? Today we are going to be dealing with, continuing, by the way, with our question paper 2016 November. Yes, of geography. Okay, so we are going to be dealing with 1.6, question 1.6, which says we must refer to figure 1.6. Okay, this is figure 1.6, which is a longitudinal profile of a river, and also shows us a river grade. So 1.6 showing river grade and longitudinal profile of a river, as I said. Okay, so question 1.6.1 says, give a geographical term to describe the irregular shape of longitudinal profile B. Okay, so let's go to B. So it says, give a geographical term to describe the irregular shape of longitudinal profile of B. Okay, let's go and see B. You can see C is smooth. Okay, let me restart. Okay, before answering, I forgot to check our figure, to check our annexure. Okay, so let's check our annexure. So our annexure at A, we have diagram A, B, C. Let's start with A as a source. It's a source there, up. Okay, it's a mouth there. Okay, proves that it's a longitudinal profile of a river. We have nick points. Okay, as you can see, we have nick points. Original sea level. Okay, this is sea level. Okay, the sea level, height above sea level, and this is first fall in sea level. Okay, second fall in sea level, and so on. Okay, B, we have a waterfall. Up there, waterfall. Yeah, waterfall erosion will exceed deposition until the feature retreats and disappears. Until the waterfall disappears. Okay, eventually possible graded profile. Okay, starting to be at least level here, smooth and being level. We have a lake here. Okay, we have a lake, as you can see. Which is caused by this steep slope and a steep slope on the outlying. Okay, yes. Okay, we have mouth. Okay, at C, diagram C, it's very smooth concave profile, decreasing in angle and gradient towards this mouth. Okay, yes, so it's smooth here. Okay, so let's go back to our question. Let's go back to our question. So our question says, give a shape of longitudinal profile B at 1 mark. Okay, you just need a term, geographical term at B. Okay, B, as you can see, is much different from C, even is much different at A. Okay, because A is at least partially graded. Okay, yes, those irregular folds will disappear as time goes by. Those nick points, by the way. Okay, so B is ungraded profile. That's your answer. Let's go write answer down. That's ungraded profile. That's an ungraded profile. Okay, that's B. That's ungraded profile. So we have 1.6.2. So 1.6.2 says name a temporary base level evident in a longitudinal profile B. So name a temporal base level evident. So let's go and look for our temporal base level. That is at which letter? At B. Temporal base level there. It's a waterfall. One. It's a waterfall. It's a lake. It's a nick point. It's a rock outcrops as well. Okay. Yes. So nick point is also there. I mentioned nick point. Yes. So let's go and write them down. So yes, so we have lake. So they said only one. Okay, I'll give you others. We have lake, we have waterfall, with nick point, we have rock outcrops as well. Okay, which are caused by the inequality of erosion and deposition. 6.3, 1.6, 1.6.3. Okay, let's move to the question. 1.6.2 says what evidence suggests that rejuvenation has taken place in longitudinal profile A. Let's go look at A. Okay, yes. So at A there is, as you can see, there is first of all there is a drop in the original sea level. Okay, there's a drop in the original sea level. Second one is that presence of the nick points or waterfalls. Okay, there's a presence of the nick points and waterfalls. Uncreated profile, as you can see it's uncreated profile, and a sudden change in gradient. Okay, the sudden change in gradient there, as you can see after moving from those two nick points. Okay, there's a change in the gradient. Okay, so let's write our answers down. So there is a drop in the original sea level. Okay, second one, presence of nick points and waterfalls. Presence of nick points, okay, or you can say waterfalls. Uncreated profile, a sudden change in gradient, as you can see it, the gradient eventually change after reaching those two nick points. Okay, sudden change in gradient. It was steeper but now it's getting gentler. Okay, any one of these. Okay, yes. So we're going straight to 1.6.4. Okay, just before 1.6.4 says describe with reasons the changes a river meander will undergo after rejuvenation. Okay, so we're describing with reasons the changes of river meander will undergo after rejuvenation. Okay, so after rejuvenation, the meander will become, I can say, will become incised. Okay, yes, incised. And also the meander will let's go there. The meander will develop steeper sides. Okay, so then the oxbow lake will then formed. Okay, yes, because those steeper sides are going to be eroded, forming a an oxbow lake or a cut of meander. Okay, let's write the answers down for 1.6.4. So the meander will drop, will become the meander will become incised. Okay, can also say the meander will develop steeper side, and you can say it will form meander will form, or it will form an oxbow lake. Okay, so 1.6.5. 1.6.5, let's move quick to 1.6.5. Okay, 1.6.5 says in a paragraph of approximately 8 lines. Okay, meaning that those 8 lines must be fertile. Okay, yes, there must be information. Explain the processes that assisted graded river in profile C. In this profile, this smooth profile. Okay, this is a smooth profile. This is a graded profile. Okay, very smooth, as you can see, from source to mouth, without even reaching your temporary base levels and so on. Okay, so explain the process that assisted the graded river in profile C to have a steep gradient in the upper course and a gradual gradient in the lower course. Okay, so mind you guys, as I taught you about this, as I told you, as I informed you in our lesson video about river grading. Yes, so if ever you lack knowledge, or yes, or you need some information and some knowledge about this, can revisit my lesson video in this channel. Okay, yes, on river gradient. Okay, yes, and morphology. Okay, okay, let's go look there. Let's give answers, by the way. Yes, we just saw that C is, let's go and give answers. So okay, let's start about the processes that are creating the steep gradient in the upper course. Okay, yes, so it's the headward erosion. Okay, so it's the headward erosion that makes it steep. Headward erosion. Okay, yes, or you can say backward erosion, because headward erosion is the same as backward erosion of what? Of nick point. Of nick, sorry, of nick points will increase the steepness of the slope. Okay, so I can also say downward erosion creates a steep gradient. So downward erosion create a steeper gradient. So mind you guys, we are still dealing with the process of creating the steep gradient in the upper course. We're still talking about the upper course, why the upper course is steep. Okay, so downward erosion create a steeper gradient because there is downward erosion in the upper course. Just to remind you, you can also say this was supposed to be like this. Let's put it like this. Okay, but you are going to write a sentence that is meaningful. Okay, yes, that is a meaning. Okay, so downward erosion, I wrote that. Okay, so the stream has enough energy to carry large particles. So the stream has enough energy to carry particles. You can also say large particles increase downward erosion. So the large particles increase downward erosion. Okay, so for the process that is creating the gradual gradient in the lower course now. Okay, yes, so you can say lateral erosion, lateral erosion. Okay, just give me a few minutes. So lateral erosion will lead to a more gradual gradient. So lateral erosion will lead to a more gradual gradient because lateral erosion is an erosion that is taking place in the sides or sideways erosion, the same as sideways erosion in the side of river edges. Okay, yes. Also the sediments are deposited in the lower course. So sediments, all of the eroded material, okay, are all deposited in the lower course. Sediments are deposited in the lower course. In the lower course, water flow is laminar. So in the lower course, the flow is laminar. But in the middle, partially, but mostly in the upper course, the flow of water there is turbulent flow. Okay, yes. So the carrying capacity is reduced due to the wider river channel. So the carrying capacity is reduced due to the wider river channels. Wider river channels. Okay. Okay, so the increase so this increases the friction on a riverbed. Okay, in a riverbed and side, and slows water flow, resulting in greater deposition rate. Yes, so this increases the friction. So sorry, didn't see that tweet down now. The friction on a river bed. Okay, and side and this slows down water flow, resulting in greater deposition rate. So that's how it goes for the processes that are creating the gradient in the lower course. Okay, so you can choose which ones you can apply, and so on, using your 8 lines and making sure that your 4 points are there, which are equals to 2 marks. Okay, yes, that's it. I wish you have a great day. See you in the next following video. Please don't forget to subscribe. Forget to remind you guys, please, if you haven't subscribed, subscribe the channel so that it can grow and so on. See you in the next following video. We're continuing with our question paper. See you. Cheers.